Hi dear students, good evening all of you. Hi dear students, welcome to Geeta's classes. Good evening all of you. Am I audible? Good evening Divya. First we'll wait for some more time. Okay, we'll solve your problem first. Yes. Okay, yes. Thank you. Thank you Sairam. Thank you Divya. Good evening Dinesh. Good evening all of you. Hope you are thorough with the previous day's problems. Have you practiced? You people have to practice the problems. Keep on practicing because practice makes permanent. Permanent in the sense what? It will be there in your mind. It will get permanent. Okay. And after that you need not even study. It will be there automatically. You can just recollect them. Okay. Yes. All of you can respond. Okay. Post your answers. All of you please do the problems along with me. This is mainly for practicing only because already I have uploaded all the classes. This is again I am doing because it is a practice for you. Mainly for practicing only. Good evening Kirtika. So all of you please do, even if you make mistakes, no problem. Even if you do slowly, no problem. Please post the answers so that you will know whether you are making mistakes or not. Okay. So it is mainly for practicing only. Please understand that because already all the topics are available in my channel. I am doing again because just for practicing and you will be thorough with the topics. When you do it again and again, it will get registered in your mind. Okay. That is the main reason I am doing it again. Right? Yes. Shall we start? Already we have completed 2 classes. Okay. And in that basic probability we have seen conditional probability, multiplicative theorem, additive theorem, base rule, everything we have completed. Now in the previous class Divya asked one doubt. That problem I am doing it here. Again it is in the first unit only. That's why I thought I'll do it again. A problem in statistics is given. And one more thing. All of you please be ready. Yeah, I'm going to explain that Divya now. The same problem only I'm going to explain now Divya. Yes. Okay, that problem only. First that problem only. A problem in statistics is given to 3 students A, B, C whose chances of solving are 1 by 2, 3 by 4 and 1 by 4 respectively. What is the probability that the problem is solved? This should be statistics, capital S. Yeah. See, what is given? There are 3 students A, B, C. All of you please listen. It is a repeated question, standard question, and the same kind of questions you can expect even for aptitude. When you in the 3rd year and final year, when you go for campus placements, these type of questions you can expect. This is a very standard question. Okay. So 3 students are there, A, B and C, right? And they are the probability that A solving the problem is 1 by 2. And probability that B can solve the problem is 3 by 4. And probability that C can solve the problem is 1 by 4. Okay. Now, what is A cannot solve the problem. Always remember A bar is and they are not related. No relationship is given between A, B, C. 3 different students. Okay. So now P of A bar, A complement is what? That means what? P of A is probability that A can solve the problem. What is P of A bar? A can probability that A cannot solve the problem. A is not able to solve the problem. That is 1 by 2. Okay, 1 minus 1 by 2. If you want, I'll write that also. 1 minus 1 by 2, which is 1 by 2. Understood? Similarly, P of B bar is probability that B cannot solve the problem. That is 1 minus 3 by 4. That is 1 by 4. Okay. And probability that C bar, that is probability that C cannot solve the problem, is 3 by 4. These are the data available with us. Okay. No, ma, Dinesh, wait. No. Not solved is not 3 by 4. Listen. There is a small twist there. You have to analyze all the possibilities. Okay. Understand the problem. Okay. You misunderstood, Dinesh. It is not 1 by 4, ma. Wait. I'll explain. Then you will. Then you can do and tell me the answer. Okay. Yeah. Shrutika, good evening. Yeah. Dinesh, please wait. Listen to this. Then you analyze. You will understand what is the mistake you have done. Okay. Listen, please. So probability that now the problem is solved. What is the probability that the problem is solved? So what are the possibilities now? Problem is solved means it can be, just they have given probability that problem is solved. What are the possibilities now? Either A can solve the problem, right? That is probability of A intersection. That means B and C are not solving. This is one possibility. Probability that B is solving the problem and A and C are not solving the problem. Probability that C is solving the problem. That is A bar intersection B bar intersection C. That is C is solving the problem. Our aim is the problem is solved. Okay. So now probability A, it can be solved either by A or by B or by C, or these are the three possibilities we have written, right? So plus. Okay. Now A and B can also solve. No. Our aim is problem should be solved, right? It may be either by A or B alone or C alone, or both A and B can solve the problem, right? Or probability that A and C can solve the problem, B is not solving, right? Even in this case, problem is solved. So probability that A and B and C can solve the problem, right? B and C. This is A and B, A and C, B and C. These are the possibilities now, right? Now, all A, B, C can also solve, right? A intersection B intersection C. So these are the possibilities, right? So you have to find out this. This means and A, B, C are independent. Therefore, you have to write P of A into P of B bar into P of C bar plus etc. for all the 7. But what is left out now? Only possibility which is left out is P of nobody is solving, right? So problem is solved means either by A or B or by C or by A and B, A and C, B and C, or 3 of them, A, B and C, right? Therefore now only left out is probability that nobody is solved. Nobody can solve the problem. That is problem is not solved. So these 7 are problem is solved. Okay, these are the cases for problem is solved, and this is the only possibility that problem is not solved. Problem is not solved. Okay, so now I think Divya, you understood. Instead of finding 1, 2, 3, 4, 5, 6, 7, we can, the total probability is 1. So 1 minus P of A bar intersection B bar intersection C bar will be easier. Understood? Yes. Yes, Manaswini. Actually, this is what we have done in the channel. One problem we have done. Okay. So Divya asked why should we take complement? Directly we can write. Okay. That's why I am explaining this. Yes, ma. This is the way you have to do. 1 minus P of A complement intersection B complement intersection C complement. Okay. So this will be easier. So 1 minus, because all are independent, you can write P of A bar into P of B bar into P of C bar that is equal to 1 minus A bar, B bar, C bar. Here it is 1 by 2, 1 by 2, 1 by 4 and 3 by 4. So 1 minus 1 by 2 into 1 by 4 into 3 by 4. Okay, this I have explained because this problem is very important. Even in aptitude, these kind of questions you can expect. Okay, so 1 minus 3 by 32, that is 29 by 32. Yes, Shrutika. Yes, ma. So actually the question is, a problem in statistics is given to 3 students A, B, C, whose chances of solving, that is probability that A can solve is 1 by 2, probability that B can solve is 3 by 4, probability that C can solve is 1 by 4. These are the values given. Okay, and P of A bar, complement of this you find out, that is P, probability that A cannot solve is 1 by 2, probability that B cannot solve is 1 by 4, probability that C cannot solve is 3 by 4. These are the values available. Okay, now the question is, what is the probability that the problem is solved? By whom or any other condition? Nothing is given. Okay, what is given? Only the problem is solved. It may be by A. This is what the conditions. It may be by A, it may be by B, it may be by C. Okay, this is what I have written. See, possibilities are, it may be by A. A is solving and B and C are not solving. B is able to solve, A and C are not solving. C alone is solving, A and B are not solving. These are the possibilities. This is taken one at a time. Similarly, A and B can solve, C cannot solve. This is another possibility. These are all the possibilities. A and C can solve, B cannot solve. B and C can solve, A cannot solve. Like this, right? And P of A intersection B intersection C. All the three can solve. So only left out is this one. P of the problem is not solved. All these 7 values are for solved condition, and the last one is for not solved. Okay, so instead of finding 1, 2, 3, 4, 5, 6, 7 conditions, you can find out the, the total probability is always 1. Therefore 1 minus P of A bar intersection B bar intersection C bar. Got it, Shrutika? Yes. Dinesh, 1 minus 3 by 32. Very excellent. Now you understood, right? Yeah, Subair, yes ma, 29 by 32. Very good, all of you. Manaswini, correct, 29 by 32. Dinesh, understood, right? Yeah, yes ma. So now we will see, next topic is random variable. So first half is over. More than 60-70% of the first unit is over now. Okay, now it is random variable. In random variable, what is the definition of random? Even defined random variable theory can also be asked. So be thorough with that. Random variable means what? A real variable capital X whose value is determined by the outcome of a random experiment is called a random variable. Okay, yes, understood. Yes, ma, Shrutika, correct. Okay, good. So now it is a real valued function. What do you mean by random variable? Why do we need random variable? See, I am having one experiment. I am tossing 3 coins. Tossing 3 coins. Okay, what is the sample space? What you will get? H, 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 T, H, T, H, T, H, H, T, H, H, T, H, H, T is over, H, T, T, and T, H, T, then T, T, H, T, T, T. Totally there should be 3 coins, no? So 2 per 3, 8 values should be there. Yeah. So if you want to do some mathematical operations using these outcomes, these are the outcomes. What do you mean by sample space? Outcomes of the experiment. So all possibilities you have to write. These are all the possibilities. Now, if you want to do some mathematical calculations using this, if you want to analyze something using applying some formula in the using mathematics, it is not at all possible, right? So what we are going to do is define some variable capital X. For this, you can define this as number of tails or number of heads. Okay, number of heads is 2. Number of heads. X is number of heads. So what are the values you can assign for X? Here I have 3 heads, right? So I can assign 3. Here I have 1, 2, 2, 2. So only 2 once I will write. You need not write twice. Okay, 3 times you are getting 2 heads, right? Here in this, for all the outcomes, number of heads, it is 1. And here no heads at all, so 0. So X is the random variable. We are assigning some number to the outcomes of the sample space. That is our random variable. Okay. So X is the number of heads, you can say. Or you can say, you can define another variable for the same sample space. You can define any number of random variables you can define. So Y is the square of number of tails. Square of number of tails, you can say. Number of tails means what? Now how many number of tails you have? Y can take the values. You can have number of tails means here it is 0. Y can take the value 0, 1, 2, 3. But here what is is it the number of tails alone? No, square of it. So 0 squared, 1 squared, 2 squared, 3 squared. So 0, 1, 4, 9 are the values Y can take. Okay, understood? So random variable is a number, that is you are assigning, you are defining a real valued function. It is a real valued function defined on the sample space S of random experiment. So any random experiment is conducted, you will get some outcomes, that is called the sample space. From the outcomes you can assign some value. So a real variable capital X whose value is determined by the outcome of a random experiment is called a random variable. Okay. So a real variable, it can be any number, any real number can be assigned to this X from the outcome of this experiment. Okay. So this is the sample space. Sample space means what? Outcome of some experiment. Okay, understood? Yes. And now discrete, first before going to discrete random variable, you should understand the difference between discrete function and continuous function. I always give one nice example so that you will never forget this difference between discrete and continuous. See, in your class, some students are there. The students' numbers are assigned as 1, 2, 3, 4 up to 60 students are there in a classroom. Okay. I want the height of I am assigning some number. I want the height of the students. Okay. It may be 5.5 or in centimeters we'll write. These are the numbers, roll numbers of the students. Okay. Roll numbers of students, that means human beings, right? Now you are assigning some value for each one. I am defining, I want to know the height of each students, height of the students. So 160 centimeter, 150 centimeter, 155 centimeter, etc., 170 centimeter. Okay. Now if I want to find out, see how many students are there? 1, 2, 3, 4, 5, 6, 7, etc. up to 60 students are there. If I want to find out the student of 6.5, can you find out the height of the student 6.5? These are all roll numbers of the students, that is human beings, right? How will you find out this 6.5? It is not existing at all. It does not exist, isn't it? See, for one person, we have assigned the roll number 1. For another person, the next person is assigned the roll number 2, etc. Right? And we are assigning some numbers for this. If you want to find out 5.5 or 6.3. For 6.3 or 6.5, what is the height? Can you assign? It is not at all possible. Okay, therefore it is discrete. That means in between you will not have any value. That is discrete function, right? Now, that is for these numbers in between, any number if you want to find out, it is not at all defined. Okay, that is discrete. For continuous, see, I always give this example because it is very easy to remember. In Hyderabad, I am taking the temperature in Hyderabad at 8 a.m. Okay, at 8 a.m. I am taking, at 9 a.m. I am taking, I am at 10 a.m. I am taking. At 8 a.m. it is around 18 degrees, right? Now at 9 a.m., 8 a.m., 9 a.m. At 9 a.m. it is around 20 degrees, right? At 10 a.m. it is 21 degrees, right? But now this is also, you may think that it is discrete, but it is not discrete because this is time and this is the temperature of a particular place, that is in Hyderabad. The time at 8 a.m. temperature is this one, 9 a.m. temperature is this one. If I want to find out the temperature at 8:05 a.m., is it possible? In the previous example, I told you for 6.5, the student 6.5, it does not exist. We cannot find out, but here we can find out. At 8:05 a.m., I have not noted down, that's all. Okay, at 8:05 a.m. it is existing. The temperature is there, available, right? So 8:05 or even not even 8:05, 8:1 I can take. Even this is even in seconds also. 8:1, 20 seconds, 30 seconds, even 1 second. In between, infinite number of values are there in between 8 and 9. Understood? So for this infinite number of values, you can find out. Therefore, it is continuous. In between, for the values, if you can assign this function, it is called continuous. Understood the difference between discrete and continuous? So discrete means in between for values you cannot find out. For continuous means even in between two values, infinite number of values will be there. Okay. Now if you read, you will understand. If a random variable is different, discrete random variable is another one. Okay. Random variable, just now I have explained, for the outcomes of the sample space, we are assigning some numbers. It is a function, real valued function. Okay. Now, if the random variable takes a countable number of values, it is called discrete random variables. Countable means 1, 2, 3, 4, only integers. Okay. That is a real valued function defined on a discrete sample space is called a discrete random variable. Last time they asked to define random variable. Okay. In 2019, I think, in the paper, define random variable was also there in the question. Now, we have seen discrete random variable. For discrete random variable, probability mass function, we define probability mass function. Now itself you try to understand now itself, okay? And you should be able to write all these things in the exam even if it is asked for theory. Theory means 2 marks, 3 marks, but I don't know in this semester, coming semester, whether they are going to keep that 10 questions, I mean 5 units only. 5 out of 8, or they are going back to the same previous pattern, we don't know. Okay, so only towards the end we will come to know, but you need not bother about this pattern at all. You just study. Okay, whatever is asked according to the question requirement, you can write them properly. Okay, so need not worry about the pattern and all, how it is going to be, whether they are going to give 5 marks, 3 marks, nothing. You study the topics, right? So probability mass function. So X be a discrete random. Always remember, for discrete random variable only we define PMF. For continuous random variable, we will find out probability density function. This is probability mass function, PMF. for continuous probability density function PDF. Okay. So let x be a discrete random variable taking values x1, x2, etc. With each possible outcome, we associate a number pi. We are going to define a probability for each value of the random variable, and such that the condition should be, because this is probability function. Okay, we are telling that this is probability mass function. No, therefore each value should be greater than 0. Because it is probability, it should be greater than 0, and the total probability is always 1. P of xi is equal to 1. Okay, so the function p is called the PMF of the random variable x. So we are defining for each value of x random variable, we are assigning some value pi such that it should satisfy these two conditions. Using these conditions only, we are going to do the problems. Okay. So next is expectation. So please remember, here two conditions are there. The discrete random variable capital X takes the values x1, x2, etc. xn. For each value you are assigning p of x is equal to xi. Okay. So this is p1, p2, etc. pn, such that each pi should be greater than or equal to 0, and sigma pi, that is the total probability, is always 1. Remember these two conditions. Okay. Next is expectation. If x is a discrete random variable which can be assigned x1, x2, etc. xn, and their probabilities are p1, p2. Just now we have seen, no? So here this you have to remember. E of expectation means E of x. I'll write in the next page so that it will be easy. Now you also write and by heart now itself. E of expectation of x means sigma I varies from 1 to infinity xi pi. Okay. And E of x squared. Here if you have x, here we have written xi, right? If you have x squared, here I varies from 1 to infinity xi squared. Whatever is there here, that thing you have to write. Suppose if you have x cube, here it should be xi cube, and so on. If you have xk in general, x per k or x per n, sigma I varies from 1 to infinity xi per k into p. Whatever is there, you write accordingly. Here you will have capital letter and here you have small xi. Okay. So now you can understand here. Xi pi, xi squared pi, xi per k into pi. Okay. Now next is mean. The mean of a random variable is the expectation of the random variable and is denoted by mu. Very simple. Just now we have seen, no, E of x. That is nothing but that is called the mean. That is mu. Okay. Next is variance. Variance, you remember this formula. Variance of x is equal to E of x squared minus mu squared. Okay. E of x the whole square, that is mu squared. E of x the whole squared. We know just now we have seen E of x is mu. So E of x squared minus mu squared. Right. This is the formula. Mean, variance. Now cumulative probability distribution or probability distribution function. Either sometimes they call it as cumulative distribution function or sometimes just distribution. Distribution function means it is cumulative distribution function. Okay. For continuous random variable, we say that it is just distribution function. And here also sometimes it is called distribution function alone. Then it is up to the point p of x is equal to x less than or equal to x. For some questions they will ask you to find out all these things. Okay. And next is continuous random variable. Till now if you have any doubt you can ask me. Otherwise we will go to continuous random variable. Understood all of you? Any doubts in this? Isma? If you have any doubt, tell me. I'll clear. Otherwise, we'll go to continuous random variable. exponential gamma uniform distribution problems I have not yet done, ma. I'll do along with this. When we start this unit, we will do that. Okay. Uniform distribution, exponential and gamma I have not completed. Only those 3 topics are left. Okay. Yes. Shivakumar, once again, okay. Probability, I think you can go through, no? Okay. That's why I'm uploading in YouTube, because you can go through again. Okay. So random variable I have defined. Quickly I'll explain again. Random variable is a number assigned to the outcomes of the outcomes of the experiment. Okay. In the sample space, for elements of sample space, we are assigning some numbers just for our convenience. Okay. Convenience in the sum calculation according to the requirement. Okay. So now in the random variable, there are 2 different types of random variables. One is discrete random variable and continuous random variable. If you are asked to define the random variable, you have to mention these 2 also, discrete and continuous random variables also. Okay. So discrete random variable, it takes only the countable number of values. That is, if you have x1, x2, etc., in between there will not be any value. That is, the function is not defined for in between values. Then it is called discrete random variable. Okay. Then next is probability mass function is defined for discrete random variable only. Right. And continuous random variable, it is probability density function that we are going to see next. So probability mass function is defined for each value of x1, x2, etc. We are assigning some values. For each x1, x2, etc. X is the random variable. Because it is discrete random variable, it is assigned some values x1, x2, etc. xn. For each value, you are assigning some probability p1, p2, etc. pn. I'll give you one problem also. You will understand how to write the probability also. Okay. So this is the function defined. And the probability is defined such that the probabilities should be always greater than or equal to 0. And the total probability is always 1. Sigma pi is equal to 1. Now if you understand, if you read this, you will understand. So now with each possible outcome xi, we associate a number pi, okay, called the probability of xi, which satisfies the condition p of xi greater than 0 and total probability is always 1. It is called, if you are defining a function p such that it satisfies these conditions, it is called the probability mass function of the random variable capital X. Okay. And expectation E of, yeah, Sridhar, I am explaining again. Yeah, already Shivakumar asked, I am explaining again. Okay. Listen. Yeah, expectation. So expectation means E of x, E of x squared, etc. Whatever you are writing here, that should be there in the right hand side. Okay. So E of x is sigma I varies from 1 to infinity xi pi. And here you have, since you have x squared, it is xi squared, right? And x power k, because here you have x power k, you have small xi power k into pi. Okay, whatever is there in the left hand side, expectation of what? You find out here from this. If you have x, here you have xi. Here if you have x squared, then it is xi squared and so on. Okay, in the power, whatever is there inside this, you have to write accordingly. That is the expectation. Okay, next is mean. E of x, expectation of just the variable x is called the mean. That is sigma I varies from 1 to infinity xi into pi. Along with me, you also study. Okay, so that it will be over. So mu is E of x is equal to sigma I varies from 1 to infinity xi into pi. Okay. Now variance means you have to remember this formula, E of x squared minus E of x the whole square. Very simple. Variance of x is E of x squared minus E of x the whole square. Or you can remember this also, E of x squared minus mu squared. We know that this E of x is our mu, right? Therefore E of x is mu. So therefore E of x squared minus mu squared. Okay, got it? This is the variance. And cumulative probability distribution or just distribution function is defined as this one. That is probability of up to the point xi. Okay, up to which point whatever is asked you have to find out. You have to add all the previous values. That is cumulative probability distribution. In my channel we have done one problem like this. Okay, find the cumulative distribution. There I have given enough explanation. Okay, every word by word, x is equal to 0, 1, everything, etc. If we have time we will do problems here also. Okay, so this is cumulative means up to that point. Please remember, cumulative means it is adding. Okay, adding up to the point. Up to that point what is the probability? Okay, that should be cumulative probability distribution function. Understood? Understood, Sridhar, Shivakumar? Yeah, Subair, I'll upload all these things. Okay, anyway, in this series we will cover. Before this series we will cover all those things. Yes. Yes, understood, Sridhar? Hope you understood. Shall we go to continuous random variable? Almost everything, whatever we have done in discrete, it is almost same. Wherever you have sigma, you have to replace it by integral. That's all. That is the only difference you will find between discrete and continuous. Okay. Yes. Yes, ma. Thank you, Shivakumar. Yeah, continuous random variable is said to be. Just now I have explained what is continuous. What is the difference between continuous and discrete, right? So a random variable is said to be continuous if it can take all possible values between certain limits. Okay, suppose if you have a comma b, that is 1 comma 2, then in between also, suppose if you have, as I have told you the example, 8 a.m., 9 a.m., 10 a.m. we are taking the temperatures. In between also we have infinite number of values for which at those times we can take the temperature. The temperature are existing. Understood? Yes. So when its different values cannot be, and this is another way of putting it, its different values cannot be put in one-to-one correspondence with a set of positive integers. As I have told you in integers, I mean height of the students I have explained, no? So 1, 2, 3, etc. All those values can be assigned. For 1 I can assign the number 1, 2, 3, etc. Integers can be assigned. Even if in the other class, for example, 61, 62, etc. up to 120 students are there. For 61 I can assign 1. For 62 I can assign 2. That is one-to-one correspondence between the number integers and the values. If there is one-to-one correspondence, it is discrete. If there is no one-to-one correspondence, then it is called the continuous. Okay. Now you cannot assign. Suppose for example 8 a.m. I am taking, 1 a.m. I am assigning some value. That is, if I assign 1 here, 2 here, in between is there, can you say that there is no other value? No. There are 60 seconds, right? So 60 seconds in between, 1 second, 2 second, etc. Even millisecond also can be calculated. That's why I told you infinite number of values are there. Okay. Therefore, you cannot assign one-to-one function correspondence with set of positive integers. Okay. Now let us find out PDF. The same thing for px we have defined there. The same thing I am assigning f of x. F of x we are writing, it is a standard variable because always we are used to know integral means f of x dx. Some function of x dx. That is why we are assigning f of x is again the probability only. Then only we can say that it is a probability function. Okay. So the probability density function PDF. I have told you for discrete it is PMF and for continuous it is PDF. Please remember. It is probability mass function and sigma. Here it is probability density function integral. Okay. So the probability density function of a continuous random variable x denoted by f of x has the following properties. It should be greater than or equal to 0 because it is a probability, right? And the total probability is 1. That is why integration. You are integrating all the values from minus infinity to plus infinity. It should be equal to 1. Okay. and the probability P of E is well defined for any event A, because we are going to integrate. No, the integral should exist. Okay, that is why it should be well defined for any event A. You should be able to find out some values. Okay. Next is cumulative distribution function. There we have told that it is sigma up to that value, right? Here it is integral minus infinity to x. Okay. Here P of x less than or equal to x means what? Xi means P of x equal to x naught plus or x1, P of x equal to x2, x1 plus etc. P of x equal to xi. Suppose if you want to find out less than 5, x5, then you have to write up to x5. Here you cannot find out like that. So in my integral minus infinity to x. This is important. Okay. Find the distribution function of. Last time they asked define the distribution function also. Okay. So capital F of x is defined by P of x less than or equal to x. Okay. It is from minus infinity to plus infinity for continuous. Again mean, here also the same thing. Here, there we had sigma, here we have minus infinity to plus infinity. And from minus infinity to plus infinity, it need not be defined. Here it is going up to minus infinity and right side it is plus infinity. It can be defined, the given function can be defined from A to B. All the others, else it will be given 0 otherwise. Elsewhere, 0 elsewhere. Okay. So only in this the interval, if it is defined, then you can write integral A to B x into f of x dx. Here again e of x squared. Variance, how will you find out then? E of x squared minus mu squared, right? E of x squared is what? Integral minus infinity to plus infinity x squared f of x dx minus mu squared. Okay. Sometimes it is defined like this. Variance means what? How much it is varying from its mean. That is why x minus mu. Okay. X minus mu the whole square. That is variance. Okay. And now according to the definition you can write like this, or if you expand you will get this. Integral minus infinity to plus infinity x squared f of x dx minus mu squared. Okay. There we have written sigma. Wherever you have written sigma, just replace it by integral. That is the only difference. Okay. We will do one problem for understanding this probability. How you are going to define the probability. Now read the question. The best book is S-Chand is more than sufficient for many problems are there. But COSM S-Chand is, I don't think it is available. You can get a previous copy as probability and statistics by S-Chand. That is 3 authors will be there. 3 or 4 authors, TKV, Iyengar and others. Okay, S-Chand book, if it is available, you can see. Probability and statistics by S-Chand publications. Previous one, old books you can take. In this, in which you have to check that stochastic process is there or not. Previously we had queuing theory, stochastic process and all. But if stochastic process is there, everything will be available in that. Okay. You can take the old book. You can buy the old book. It is 2013, I think. 13 series. Probability and statistics by S-Chand. That will be very helpful for you. Okay. That's what in R13 it is not there. You otherwise no. Actually probability and statistics R13. One light green color book. There everything is available. In that you check stochastic process is there, all the other things will be available. All the other things will be available in that. Okay. But I am trying to cover all the topics more. All these topics will be covered. And many more problems also, extra problems we are doing now. So if you understand these concepts, it will be very easy. That's why I am giving you the assurance. Okay. I am giving you the assurance that you can clear COSM, because if you understand these concepts, any problems you will be able to do. That's why I am explaining in detail. Got it? Yes. If you don't have any book, I mean, if you, which topic is not available, you tell me. According to my knowledge, all the topics are available in that, in this yes Chand, okay. But your textbook is the different one. In the next class, Wednesday's class, I'll upload that book's first page, okay. Yes, that is your textbook, but problems will be lesser in that. For practicing problems, you can use yes Chand. Okay, and concepts, most of the concepts I'm explaining from your textbook only, right? Yeah, problems you can take from any other books also. Yes ma, F test, T test, everything is there. T test and all I have done already. 8 o'clock ma, Monday, Wednesday and Friday. If you subscribe, you will get the notification, okay. And every 3 alternate days, I mean Monday, Wednesday, Friday I'm planning. If time is not sufficient, towards the end we'll have every day. Depends on the response, okay. If you people want, and depending on the requirement, we will change, okay, towards the end. Because now we have time 1.5 months. January 2nd week you will have exams, right? Yes. Now read the question. What Shrutika? 1, 2, 3. See, 10 items are there containing 3 defectives. Totally there are 10 items and 3 defective items are there. I want to choose 4 items. Okay, a sample of 4 items is drawn at random. Let the random variable capital X denote the number of defective items in the sample. Find the probability mass function of X when the sample is drawn without replacement. Without replacement. Okay. So, and Shivakumar, I forgot to tell you 8 to 8 to 9 maximum. Okay. Okay, I am always there to support you. Don't worry. Okay. Yes. My aim is to make you clear the paper. All my students, engineering students, should not say that maths is difficult. That is my aim. Okay. All my students should know mathematics. They should understand. The problem is you till now you have not understood anything, just by heart and go. No. That is why you people are finding it difficult. Now if you understood, now even random variable, all those things, whatever I have explained, you will never forget. That is why I'm trying to give examples and it will be there in your mind. Okay, as I always say, practice makes permanent. Okay, and if you practice, you will never forget these things. It will not be difficult at all. Okay, yes. Yeah, 10 items are there, 3 defective items are there. Let the random variable X denote the number of defective items in the sample. Find the probability mass function X when the sample is drawn without replacement. When the sample is drawn without replacement. So what are the possibilities we can get? What are the possibilities we can get? I am choosing how many items? 4 items I am choosing. Right? I am taking 4 items. In that, how many, what are the possibilities? I will write this as bad item and good item, defective or non-defective. So just for understanding, we can write bad and good. Okay, bad means defective items. Okay, so 0 bad items and 4 good items. Okay, or it can be 1 bad item and 3 good items. These are the possibilities. It may be 2 bad and 2 good, 3 bad and 1 good. And is it possible 4 bad and 0 good? Is it possible? Is it possible? Tell me the last possibility. Is it there? Can I take 4 bad items and 0 good items? Is it possible? I want to take 4 items from that lot, right? From the lot I want to take 4 items and 0, 4, 1, 3, 2, 2, 3, 1, 4, 0. Is it there or not? Can I take it or not? It is not possible because, anyone? Because last possibility is not there. Because, what is the reason? Ravindra, tell me the reason ma. Yes, very good. No. Yes, very good. I cannot take. What is the reason? Yes, no. Yes, ma. Why? Why I cannot take 40? Reason? Anyone? Reason? Anyone? Anyone? You need not delete Shrutika, no problem. It is 0. No, ma, 0 good. No, 4 items, no. See, all the 4 can be bad, right? See, from 10 items, yes, very good. Shrutika, only 3 defective. Yes, very good. Ravindra, 0 is possible. Okay, Nagalakshmi, only 3 defective items are available. Yes, very good, very good. Yes, Divya, no ma'am. Yes, ma'am. Understood, right? So, because only 3 defectives are available, right? I want to take 4 items. So, only 3 is possible. So, these are the possibilities. Either this can be there, or this can be there, or this can be there, this can be there. So, what are the possibilities I can take now? Capital X can be, 0 defective can be there. I want, what is X? X denotes the number of defective items. Here, these are the defective items, right? So, capital X can be 0, 1, 2 or 3. Yes. Yes, ma. Number of defective items are only 3. Yes, very good. Understood, right? Yeah. Which should be 4, ma? Shrutika, Kirtika, no ma. It is 4 only. Yeah, 4 we have to take. Hope you understood. Okay, only 3 defective items are there. So 4 I cannot take. Because in total 10 items, only 3 defective items are there. Understood? Therefore, I cannot take more than that. Got it? Yes. So now, what is the question? Find the probability mass. This is the random variable is defined now. What are the values we can assign for this? X, 0, 1, 2, 3. Right? These are the values we can assign. Now, find the probability mass function of X. That is, for X is equal to 0, 1, 2 and 3. What are the probabilities you can assign? What is the probability that there are 0 items, 1 item and so on? See, I'll write again. There are 4 items. So, possibilities are 0, 4, 1, 3, 2, 2 and 3, 1. Okay. How many are there? 10 items are there totally. And 3 defectives are there. 3 defective means what? 7 are not good items. 7 non-defective. 7 items are non-defective. Yeah, Kirtika. Okay. Okay, ma. So, 7 non-defective, 3 defectives. Okay. Now, these are bad and good, right? Now, what is the required probability? When X is equal to 0. That is probability of X is equal to 0. This is the first one. So, how many bad items are there? 3 bad items are there. I am getting 3Z0. I am taking 3C0. Okay. And 4, from how many non-defective items are there? 7. So, from 7, I am taking 4. So, 7C4. So, total is always written. From 10 items, I am taking 4 items. Therefore, 10C4. Okay. And in the numerator, number of favorable items. Favorable cases is 3C0, which is 1 and 7C4. Right? Similarly, probability that X is equal to 1 is bad items. Now, how many bad items are there? 3 defectives are there. So, from 3 I am going to take 3C1 and from 7 I am going to take 3 good items. Okay. So, 3C1 into 7C3. Why it is into? I want all the 4 items. I am taking 1 from bad and 3 from good. This should happen and this should happen. Okay. So, when to take R and all, I have given explanations in the permutation combination basics. How to take R, how to take and all. If you want, you can go through them. Okay. So, 3C1 into 7C3. How many total? 10C4. Okay. And actually, I am giving the same explanation here also. But many more examples you will get in that. Right. So, here for 2, 3C2 into 7C2 divided by 10C4 and P of X is equal to 3 is 3C3 into 7C1 divided by 10C4. Please simplify and tell me the values. Simplify and tell me the values. For x is equal to 0, 1, 2, 3. And you have to tabulate them, okay? Because it is asked for PMF, you have to tabulate them. X is equal to 0, what is the probability? For 1, what is the probability? What is for 2 and 3? Okay, I'll write the values, you can check later. 1 by 6. Do you know how to expand this? 7C4 is equal to 7C3. So 7 into 6 into 5 divided by 1 into 2 into 3 divided by 10 into 9 into 8 into 7 divided by 1 into 2 into 3 into 4. This is how you have to expand. Yes, ma, without replacement only. Okay. Probability mass function of x when the sample is drawn. Yeah, correct only. Without replacement is okay. Here, see, either this can happen. 0 means only 0. Only 4 items we are taking. Okay. Only 4 good items we are taking. You need not worry about that without replacement here, ma, because probability mass function of x here. X denotes the defective items only, no? X denotes the number of defective items. Okay, and probability mass function when the sample is drawn. See, 4 we are taking at a time. At a time. It is not, you need not bother about that without replacement. It does not have any work here. Okay, so here only 4, either 0, 4 or 1, 3 or 2, 2 or 3, 1. Right? Understood, Shrutika? Okay, yes. So 1 by 6 for 1, this is correct only. X is equal to 0. See, if you are writing the probability 1 by 1 separately, then you have to bother about. Now it is not required. 7C4 you are taking at a time, 4. Okay. 4 items is drawn at random. If it is one after the other, then only you have to bother about that. It is not mentioned like that. A sample of 4 items is drawn at random. Okay? Yes. Understood, Shrutika? So for 1, it is, when you simplify here, you will be getting 1 by 6 more, all these things, 1, 2, 3. You cancel all these things, then you find out. Okay? So it will be 1 by 6. You can check these values later. 1 by 2. Then 3 by 10 here. That's what see, if the statement is given like this. 4 items are drawn one after the other. Then with replacement, without replacement, you have to use. Okay. Shrutika. Sample 4, a sample of 4 items are drawn at random. 4 items is drawn at random. That means at a time simultaneously you are taking 4. Okay. If here it is mentioned that 4 items are drawn one after the other, then you should bother about whether it is without or with replacement. Okay, understood? Yes, ma. Okay, good. So here the values are 3 by 10 and 1 by 30. Hope all of you will get this. Okay. Please work out and do it. Just simplify this. 3 by 10. So this is what is asked. Probability mass function means x values and the corresponding probabilities. Okay. Actually this problem we thought of doing, okay, we'll see in the next class. Now it is almost 1 hour. Enough. Okay. That mean we'll do in the next class more. If you have any other doubt, you can ask me, otherwise we'll wind up. Any other doubts? Whatever till now, whatever we have done, you can ask. Any other doubts? Shall we close then? Okay, thank you for listening. Thank you for attending live. Okay, thank you, Kritika. If you are new to the channel, please subscribe so that you will get notifications. Okay, and if you like the class, give a thumbs up. And if you feel that it is useful for you, and if you want to support the channel, please share it with your friends also. Thank you so much. Shivakumar, this is first unit, ma. This is first unit, Shivakumar. We are still in first unit only. Okay. Yes. Any other doubts? Shall we close? Yes, ma. And next is Wednesday. Okay, Wednesday we'll meet at 8 o'clock. Thank you so much for joining.